Hello. So we have studied 4 novel processes, general processes. Till now, we have studied isochoric process, isobaric process, isothermal, as well as the adiabatic process. There are some specific processes. Now, what we will do, we'll study a general process, and we will form the formulas corresponding to the general process. And with those formulas, we'll calculate each and everything. Okay. So whenever any question will be given to you, and if that question involves a process which is not under those 4 specific processes, you can solve that question using the general process. Okay. So the general process I am defining as P v to the power n as constant. This is my general process. Where n is a constant, it's a number. It is a real number basically. It can be a negative value, it can have a positive value, it can be an integer, it can be a fraction, it can be any number, any real number. So if any process is given to you which is in this format, Pv to the power n, you will be able to solve the question directly. So what we will do, we will calculate the work done, change in internal energy, as well as the heat given in the process for this process, and we'll make the formula for those. Okay. So first of all, we will learn how to compare this process with the process which will be given to you in the question. That we will learn. So see, Pv to the power n is a constant. This is our general process. Now let's say in a question you are given a process which is P t to the power minus 2 is constant. That kind of process you are given. Examiner might give you this process in the equation format, or he might make the graph for that. So if the graph is given to you, you will convert that graph into the process, okay, or the direct equation you will use. So P t to the power minus 2, the process is given to you, and this equation is nothing like the equation which I am taking for my general process. So what you will do, first of all, you have to convert this equation in this format. And in this format, there are pressure and there is volume. And here you see there is pressure and there is a temperature. So you have to convert the temperature first. How to do that? We have an ideal gas equation. So ideal gas equation, which says PV is equals to nRT. So we have to convert the temperature here. So what we will do, in place of temperature, I'll replace the value of temperature from here. So it will be PV upon nR to the power minus 2 is constant. This n and r, they are constant, so on the right hand side when we will take it, it will be a constant. So we'll have P to the power minus 2, V to the power minus 2 is another constant. Simplify this, we'll have P to the power minus 1, V to the power minus 2 is constant. And let's take left hand side onto the right hand side. If we take left hand side onto the right hand side, we'll have PV square is constant, because we'll have 1 upon P to the power minus 1 which will become P, and 1 upon V to the power minus 2 which will become V square. So this is my process. This equation represents this equation. We have got this equation by converting it. So if I convert this with my general equation, comparing with general equation which says Pv to the power n constant. If we compare this, we'll have the value of n as 2. So whatever equation we'll be having for work done and the heat, wherever the n will be coming, what I'll do in those formulas, I'll replace the value of n by 2. And the moment I'll replace the value of this n, we'll have the ready-made formulas for work done by the gas, for the heat given to the gas, for this process. Okay. So that's how you use this formula. So what we will do, we'll calculate each and every thermodynamical variable, heat given and the work done for this process, and later on whenever the question will be given to us, which will be in this format or some other format, we'll convert that question into this format, and by comparing we'll get the value of n. And we'll put the value of n in those formulas which we have already calculated for this equation. Okay, so that is the thing. That's how you solve the question. This is like a trick basically to solve the question very fast. We don't have to derive one more time all the things for this particular question if we have already derived those things and memorized those things for this type of equation. Okay, thank you.